I just want to take a look at some examples of multiplying and simplifying radical expressions. So we have the following here. We have 5 times the square root of 8x times 3 times the square root of 2x to the 5th. So to carry this work out, we proceed as follows. First of all, it's important to remember that when the index is not given, right here, the index is implied to be 2. Do you remember that, okay? That means it's the square root or the second root if you like. But when it's not given, it's implied to be 2. Let me erase that one also. And now, let's move on. So we're going to multiply. When you multiply expressions like these, you multiply the values outside together. So the 5 times this 3. So first you're going to get 5 times 3. And then, because the indexes are the same, so again, this is, over here, this is 2, and this is also 2. So when the indexes are the same, you can just write times, and then you can put the 8x, and multiply that by the 2x to the 5th. 2x to the 5th. So you can put them under one common root symbol. And then you can simplify that as follows. 5 times 3 is 15. This becomes the following times. Now the 8 times the 2 is 16. The x times the x to the 5th is x to the 6th. Remember, that's because x to the 1st, that's what you have here, times x to the 5th is x to the 1 plus 5, which is x to the 6th. And now you carry this out. Again, here it's useful if you remember that there's a 2 in this position, okay? So 15 times, and when you have under a root symbol a product of two quantities, you can distribute the root symbol to each one individually. So you get the square root of 16 essentially, times the square root of x to the 6th. Then you get 15. The square root of 16 is 4, so that comes out as 4. At this point, when you go from 3 to 4, do not include the root symbol anymore, because the square root of 16 is 4. And now over here, remember that the following is true. When this number, an exponent, is a multiple of the index, like 6 is a multiple of 2 is true because 6 divided by 2 is 3. When that is the case, when this exponent is a multiple of the index, then to form this value right here, you just do x and then 6 divided by 2, which is that exponent of 6 divided by the index that gives you x to the 3rd. So you put x to the 3rd over here. At the next stage, that's going to give you, at step 5, 15 times 4 is 60, and then x cubed. So it's 60x cubed. This is considered the answer right here. Okay, let's do another one. It's down. Okay, so this one's a little bit different, but again, not too hard, luckily, because the indexes are the same. So this 3 and this 3 are both present. For that reason, when you have the same indexes, you copy the whole root symbol with the index, and then you multiply the expression under the root symbol together. So you have 3 times 9, so 3 times 9. Then it's x squared times x, that's x cubed. I'm multiplying this and this together, and then you multiply the y and the y squared, so it becomes y cubed. Now notice something, that here the index is 3. And you've got these numbers, 3 times 9. So we need to take the 3 times the 9 and rewrite it somehow, so it also shows an exponent of 3, so it can cancel with the index. So to do that, I'm going to rewrite the 9 as 3 squared. So it becomes 3 times 3 squared times x cubed times y cubed. And then, let me push this down. So then it becomes the following at this next step. Third root, or the cube root if you like. Then it's 3 times 3 squared, which is 3 cubed. And you see how when you bring it into that form, the index and the exponent match. Then it's x cubed, then it's y cubed. You can obviously bypass some of these steps. You don't have to be as detailed as I am, but... And then, you can distribute the root symbol to each factor individually. Remember that the 3 cubed is a factor, the x cubed is a factor, and the y cubed is a factor because they're being multiplied together. So you're going to now have the third root of 3 cubed times the third root of x cubed times the cube root of y cubed. So when you simplify all of this, it comes out as follows. This cancels with that, is just 3. This cancels with that, is x. This cancels with that, is just y. So it becomes 3xy. That's it. In its fully simplified form. And the last one involves division. But again, this is a bit rigged because it's... Take a look. The indexes are the same. So even in division, let me zoom in here. When the indexes are the same, so when this value matches this value, you have the same indexes. When that is true, then you can easily do this. Take a look. You can put... Let me switch the pen here. So you can easily write... You can put one giant fourth root symbol like this. You can distribute that root symbol, in other words, out. and then you put the rest of it, whatever that happens to be. So let's see, in our case, it's the following. You're going to put x to the 10th, and it's going to be y to the 9th, then it's going to be x to the 6th, then it's going to be y to the 5th. So again, because in the original division, the indexes are the same, you can just rewrite that problem. So there's only one root symbol with that same index. Make sure that you don't change this index here to something different, that it stays at 4, okay? Right here. Make sure that stays at a 4. Then after that, let's take a look at the next one. The next stage is to simplify under the root symbol. So you're going to have x to the 10th divided by x to the 6th. That's going to be x to the 4th. Remember, that is so because it's x to the 10th over x to the 6th is x to the 10 minus 6, which is 4. So this becomes x to the 4. For the other portion, let me erase this a little bit over here, clean that up. You're going to have y to the 9th divided by y to the 5th. That's y to the 4th. See that? So again, y to the 9th over y to the 5th is y to the 4th. 9 minus 5 is 4. That's 1. And then you simplify this again. So if you want it to be very formal, you would simplify by distributing the root symbol to each factor under the root symbol individually. So you do the 4th root of x to the 4th times the 4th root of y to the 4th. If you want to be very formal, you do that. And then you simplify. At step number 4, you have x. And for this one, the 4th root and the 4 and the exponent cancel, and you end up with y. So this would be considered the answer here. And that's it. Thanks so much.